As you, pardon me, as you can see, this is titled Math 1325 Getting Started. And basically what we're going to do here is, over the next several pages, discuss some of the things that you should be bringing to this course that you already know, things that you might have learned in college algebra or algebra 2 in high school, and things maybe that you haven't thought about in some time, and then a little different twist on things that we do know, but maybe we haven't seen them presented that way. Because these are, whether we use it in the homework right away, or things that we'll need to be able to deal with when we have homework later on. So what I'd first like to talk about is operations on polynomial expressions. And of course, the types of operations that we might have would be addition, subtraction, multiplication, and division. So operations on polynomial expressions. Okay. Well, the first example might be one of addition, and addition. And I'm not going to belabor some of these points. I'm going to go over them quickly because I expect a lot of them you to know, and I'm just reminding you. So if we have a couple of polynomials, we'll say x squared plus 3x minus 5, and we're adding to that a polynomial that is 3x to the fourth minus 5x squared plus 2x minus 7. We're going to add those polynomials together. Well, what we remember that we need to do is we just need to remove those parentheses because there's nothing special going on in front of the parentheses. And so our next step would be, well, let's do that. X squared plus 3x minus 5 plus 3x to the fourth minus 5x squared plus 2x minus 7. And then we can combine like terms. And we like to have things in a nice order, so we may look for the highest power of x to appear, and we'll see that that's here. So we'll begin as 3x to the fourth, and there's no terms to combine with that. And then we looked at the next highest power of x is x squared, and we have two terms that involve that. 1x squared and negative 5x squared, of course, makes negative 4x squared. And then we see we have two terms involving x to the first power, and those two terms are 3x and plus 2x. 3x plus 2x, of course, is 5x. So we say plus 5x. And then we combine the two constant terms. Negative 5 minus 7, of course, is minus 12. And so we would write our answer in this fashion. Now, I know that's no big deal. But when it comes to subtraction, we may have to be a little bit careful. And I just want to remind you of that. So we could take the same two polynomials, but instead subtract. So we would have an x squared plus 3x minus 5, and we're going to subtract the polynomial 3x to the fourth minus 5x squared plus 2x minus 7. And of course, as we do that subtraction, what we have to recall is the subtraction changes. We're actually subtracting every term in that polynomial. And so when we do that, we basically change all of the signs of the polynomial. Well, let's go ahead and get started. When we have the x squared plus 3x minus 5 in those parentheses, of course, those parentheses really aren't indicating anything except saying that's one polynomial. But then we have the subtraction here, and it says we're going to subtract 3x to the fourth. Well, there's subtract 3x to the fourth. But it also says we're going to subtract a negative 5x squared. And when you subtract a negative, it becomes an addition, doesn't it? So subtracting negative 5x squared is the same thing as adding 5x squared. And then it says we're going to subtract a positive 2x. So that means minus 2x. Subtracting a positive 2x is the same thing as just saying subtract 2x. And then lastly, we've got to subtract a negative 7. And subtracting a negative 7 is the same thing as adding 7. And so the effect is that minus sign outside those second parentheses, in front of those second parentheses, change the signs of all of the terms of the polynomial. Now when we go to combine our terms, you'll see that our highest power of x once again is x to the fourth. So we begin with a negative 3x to the fourth. That minus sign belongs to that term. And then we have an x squared plus a 5x squared, which of course is 6x squared. And we have a 3x minus a 2x, which is positive 1x, or just plus x. And then we have a negative 5 plus a 7, which becomes plus 2. So there's what the subtraction would look like. Of course, the main thing to remember is how that subtraction affects the signs of the things inside the parentheses, the second polynomial. Now, we do need to be concerned about situations where we have a combination of multiplication and subtraction. So I would call this some kind of a hybrid problem, and we don't really need to worry about the terminology I'm using here. But suppose we had negative 2 times x squared plus 3x minus 5, and we were let's say, adding 4 times 3x to the fourth minus 5x squared plus 2x minus 7. So before we remove the parentheses here, we need to apply the distributive property. That is, we need to multiply out that negative 2 through the first set of parentheses. So that negative 2 multiplication is going to be important. So we end up with negative 2 times x squared, and then negative 2 times a positive 3x is minus 6x, and then a negative 2 times a negative 5, of course, is a plus 10. And so the process of that multiplication actually eliminated those parentheses, didn't it? And then we're going to begin doing the multiplication of the 4 throughout the parentheses we see there. So we think positive 4 times 3x to the fourth is positive 12x to the fourth. And that's not a plus or minus sign. I'm indicating it's a positive 4. So a positive 4 times a negative 5x squared is minus 20x squared. And a positive 4 times a positive 2x is a positive or plus 8x. And a positive 4 times a negative 27, of course, is minus 28. And now it's like the addition problems above, we just combine like terms. And so we first identify x to the fourth again as the largest term, or the largest power of x. So we begin with 12x to the fourth. And then we notice we have a negative 2x squared and a minus 20x squared, which of course is negative 22x squared. And then we have a negative 6x and a plus 8x, so that becomes plus 2x. And then, of course, we have the positive 10 and the minus 28, which becomes minus 18. And so our result here, when we simplify, is very straightforward, of course. Now, I would like to show one more example of a hybrid style. And we're not going to have homework that deals with this directly right away. But it's not going to be unusual in the future that we might have something that looks like this. And so we need to be able to deal with this scenario. So we might see something that we're asked to simplify, and it might look a little strange. And so when we go about simplifying, we may have something that looks like this. We might have an x, well, let's say a negative x, to the third power times parentheses x squared plus 1. And then we might have a minus sign, okay, and let's say maybe here we have a parenthesis and an x to the fourth power minus, well, let's say plus 1. Oh, I'm sorry. How about plus 3? Just to mix it up a little bit. Plus 3. And then times a negative, a positive, we'll just make it that way, a positive 2x like that. We're asked to simplify that expression. Now, we're going to have to do a little multiplication and a little addition and or subtraction here. So that's the reason I'm looking at it now. But before we can apply any subtractions, you notice that we have two multiplications to deal with. We have a multiplication here and a multiplication here. And we need to deal with both of those multiplications. Well, the very first one is kind of normal, but I want to talk about the second one. The second multiplication, the one that we're referring to, or I'm referring to right here, is a little bit of an issue because we have this minus sign right there. And whenever we see something that looks kind of like this, I mean, we could do the multiplication, the 2x, but we would do the multiplication before we did the subtraction. So I guess I'm mumbling a little bit here. Let's do this very first multiplication. Negative x cubed times what's in the parentheses x squared plus 1. And of course, negative x cubed times x squared is negative x to the fifth. And negative x cubed times a positive 1 is minus x cubed. Okay, so it's this next step that I'm worried about. And again, it's because of that minus sign. But remember, we have to do multiplications before we do subtractions. And so that subtraction sign is going to be there. And when we do the multiplication that's over here, when we do this multiplication, we're going to get a result that has two terms. And see, we're subtracting the result of the multiplication. And so we're going to have our result in these parentheses. Otherwise, we're going to have the wrong sign. So as we do the multiplication 2x, or x to the fourth plus 3 times 2x, we have to multiply that 2x with both of these terms. We recognize that, I hope. So 2x times x to the fourth is 2x to the fifth power. And then 2x times a positive 3 is a plus 6x. But that being the result of the multiplication, we still have a subtraction to deal with, and that's the reason we have to have that in our parentheses, because that subtraction is actually going to change all of the signs, isn't it? So we end up with this negative x to the fifth in front, minus x cubed, and this subtraction sign is going to create minus 2x to the fifth, and also minus 6x. And then when we look at all the terms involved, we have two terms that involve x to the fifth power. Negative 1 and negative 2 is negative 3x to the fifth. And then our next largest term is minus x cubed, and then finally negative 6x or minus 6x. And so that's how we would simplify that expression. And the whole issue is the second part of that. Now, I might say here that in this class, there's going to be a lot of these videos, and in these videos, you can always pause, work ahead, and see if you get the same result that I'm going to get, or you can, of course, go in reverse and also look at something more than once. So you can go back and look at it again, or you can skip ahead quite a bit. So you just figure out how you'll apply your navigating through the videos. I'm going to temporarily pause here so I can go to the next page, but in the video you won't really notice a pause. As you can see here, we're going to discuss in this section on the next few pages multiplying polynomial expressions. And once again, I know that you know how to do this, but there may be a few things that you've forgotten or we need to consider again. So let's just look at several examples. So example 1. And of course what we're doing in all of these is we're asked to multiply, of course, and simplify. Multiply and simplify. Now, we saw the use of this in the last piece, that we might have a monomial multiplier. So, for instance, we might have something like negative 3x to the, say, seventh power times, in parentheses, a 5x squared minus a 2x plus a 4, just as an example. And of course, in a situation like that, we distribute this. So we take this multiplier that's on the outside of the parentheses, and we make sure that it multiplies each of those terms. So of course that gives us negative 15x to the 9th power, x to the 7th times x squared is x to the 9th. And then next we have a negative times a negative, which becomes a positive. And of course, 3 times 2 is 6, and x to the 7th times x, which is the same as x to the 1st, is x to the 8th. So the second multiplication gives us positive 6x to the 8th. And then we have a negative times a positive in the last situation, that's negative. And of course, 3 times 4 is 12, and then of course just the x to the 7th. So simple idea, not any problem. Let's look at example 2. And just again, I'm trying to point out to you that that multiplier can be on either side of our polynomial. So we don't get anything any different if it would have been 5x squared minus 2x plus 4 multiplied with negative 3x to the 7th over on the right. Now notice I've got parentheses there, because if I didn't have those parentheses around that negative 3x to the 7th, it would look like subtract 3x to the 7th. But this is still, when we understand when those two parentheses are right next to each other and no symbol is in between, we understand it means multiplication. So we're going to do the same thing. We're just happening to multiply what's on the right. We're distributing from the right. So we'll still get a negative 15 x to the 9th plus 6x to the 8th and minus 12x to the 7th. Now, in the next example, we're multiplying maybe a couple of binomials together. And so we might have something that looks like 3x minus 4 times a 2x plus 5. And we know, of course, that what we call the process that we multiply this out with is FOIL. And I don't really care about that as I'll refer to it as FOIL, but we need to understand the process of polynomial multiplication. We'll take the 3x and make sure it multiplies the first term, and then make sure it multiplies the second term. And then we'll take the negative 4, make sure it multiplies the first term of the second polynomial, and then with the second term. So 3x times 2x, of course, is 6x squared. And then 3x times a positive 5 is plus 15x. And then we're dealing with the negative 4. Negative 4 times a positive 2x is negative 8x. And negative 4 times a positive 5 is negative 20. And that's the FOIL idea. The 3x times 2x is the f, the first. Multiply the firsts. The 3x times the positive 5 is the o. That's multiply the outsides. The negative 4 times the 2x is the I, and that stands for inners. So you multiply the two things on the inside. Negative 4 is on the inside, and 2x is on the inside. And then it's finally negative 4 times positive 5, and that's the L for lasts. Negative 4 is the last of the first, and positive 5 is the last of the second. But we can still combine these middle terms, can't we? So we rewrite this as 6x squared plus 7x minus 20. And that's the way we would leave our answer. You know how to do that. Now, let me remind you, though, that although it's not called FOIL, the same pattern works if we're dealing with something that looks like a binomial times a trinomial. So we might have something that looked like this. How about a 3x minus 2 times the trinomial 2x squared plus 6x minus 7. Now, this can't be FOIL. FOIL just refers to a binomial times a binomial. But as you recall, we do the same kind of pattern. We take this 3x and make sure that it multiplies all of these terms in the second polynomial. And then after we do that, we'll use the negative 2 and make sure it multiplies all of them. So 3x times 2x squared, of course, is 6x cubed. 3x times a positive 6 is a positive 18x squared. And 3x times a negative 7 is a minus 21x. So we're finished using the 3x, so now we move to the negative 2, and we make sure the negative 2 multiplies all the way through. Negative 2 times 2x squared is negative 4x squared. Negative 2 times plus 6x is negative 12x. And negative 2 times negative 7 is plus 14. And then we look to see whether we can combine terms, and we have no other x cubed terms, so there's nothing to combine with it. But for x squared, we have two terms, don't we? So we have a positive 18x squared minus 4x squared, which is positive 14x squared. And we have two terms involving x to the first power. That's negative 21x and minus 12x. And so that's minus 33x as we combine those. And then lastly, we just have the constant term plus 14. And so that's what our simplified form would look like. Well, these are fairly straightforward. And again, these are things I expect you to know already. But I'm reminding you. Now I'm going to turn to something that maybe you're not quite so familiar with. And in fact, well, we'll do one more example that you should be familiar with. And that's an example. Let's do this. That's an example where we're actually squaring a binomial. So for instance, we might have something that looks like 5x minus 3, and we have an exponent on that binomial. Now, this is a big issue that we go about doing this correctly. And it's not unusual that students get in a hurry and they make a silly mistake and say that's 25x squared minus 9. But that's absolutely incorrect. That we have to recognize what that exponent of 2 means. And that means we multiply those parentheses together. See, we multiply what's in the parentheses together. We say 2 times, but actually we're just multiplying once, aren't we? So we use 5x minus 3 as a factor 2 times. This really says take 5x minus 3 and multiply it with 5x minus 3. And when we recognize that, we understand that we have to use FOIL. And so the process is more complicated. 5x times 5x is 25x squared. And 5x times negative 3 is negative 15x. And negative 3 times 5x is negative 15x. And negative 3 times negative 3 is plus 9. And so you can see as we combine those middle terms, we'll have 25x squared minus 30x and plus 9. And so it's not as straightforward as just squaring a couple of pieces there. We have to go the long route. And there is a pattern to how this goes, but this is not an algebra class. And so I'm going to rely on you to either remember the pattern or just go ahead and expand it as we have and do this the long way. Now, again, I'm going to, when I start to say, well, it goes, I'm going to show you an example where it may be a little less familiar to us. So I'm going to do that on the next page. Before we actually do this multiplication problem, algebraic one, I want you to stop and think about the result you would get, okay? And this is a thought problem for you. Multiply 2 times 3 times 5. And of course, you'll quickly come back with, I think, you should come back to the result is 30. And it's not that I'm interested in the result. Here's what I want to point out to you. There are 2 multiplications there. 3 numbers, but there's 2 multiplications. And I suspect that what all of you did is you chose to do that first multiplication, 2 times 3. See, I think probably what happened is when you worked on this problem, you concentrated on that multiplication. And when you did, you got a 6. But that was just what the 2 times 3 is, and so you still have times the 5 out here, and of course 6 times 5 was 50. It was 30, pardon me. Now, we could have, and maybe some of you did this, we could have instead of concentrated on this second multiplication and said, oh, well, 3 times 5 is 15. So we've got the 2 in front and the times, but we're replacing the 3 times 5 with a 15. And now we're doing 2 times 15, and of course we get 30. So we could have done it either way, but the primary issue here is you can only perform one multiplication at a time. I mean, we didn't apply the 2 times 3 and the times 5 all at one time. We did it in pieces. So that really is the crux of how we deal with this sixth example. We're being asked in this case to multiply together x plus 2 times x minus 3 times x plus 5. Now we're multiplying three things, but we have only two multiplications, don't we? There's a multiplication right here, understood, and a multiplication right here. Now, what we need to do is decide which of these multiplications we're going to perform first. And it really doesn't matter if we perform the first one or if we perform the second one. But whichever one we decide to perform first, if we're performing this first multiplication, what you need to recognize is when we multiply those two, we're going to use FOIL. And when we use FOIL, we're going to get a result. Just like we did up above, 2 times 3 is 6. And that result is going to have to be multiplied with the last piece, x plus 5. But we need the result in parentheses because there's going to be several terms, and that's the whole thing we're using to multiply with. So we come over here to the side, and we think about, well, what is x plus 2 times x minus 3? And of course, using FOIL, we have x times x is x squared, and x times 3 is negative 3x. And then we have 2 times x, that's 2x, and 2 times negative 3, that's negative 6. And then as we combine those middle terms, we get x squared minus x minus 6. So that's our result of multiplication. So that's what we have in here, an x squared minus x minus 6. Now we're going to deal, so that's what we got when we did this multiplication, isn't it? Now we're going to deal with multiplying two polynomials. So we've got to make sure every term in the first polynomial multiplies with every term in the second. So we have to start with this x squared, and it's got to multiply both of these terms over here. So we have x squared times x, which is x cubed. We have x squared times a positive 5, which is plus 5x squared. Now we've got to take, when we're finished with x squared, so now we take this negative x and make sure it multiplies everything over here. So negative x times positive x is negative x squared. Negative x times positive 5 is minus 5x. Now we have to deal with the negative 6 in that first polynomial and make sure it multiplies both things over here. So it's going to have to multiply the x and the positive 5. So negative 6 times x is negative 6x, and negative 6 times positive 5 is negative 30. Kind of ran into some space issues, didn't I? And then we see that we can combine a couple of several terms. The 5x squared minus x squared becomes plus 4x squared, doesn't it? And the the negative 5x minus 6x becomes minus 11x, and then of course minus 30. And so our final result then looks like this. Well, the main issue is one multiplication at a time. So we have to break the problem up into pieces to get things accomplished. Okay. And not always, I will also point out, not always do we get every single term from highest power to lowest power. We just did in this particular case. Well, the next thing I want us to know about is dealing with factoring. And I'm going to go over quickly some factoring techniques, but I'm going to do that in the next section, or on the next page.